Hello, students. Okay, so I'm going to go over Ab Frq 2012 number 3, which is the one that you were assigned on Friday. So it talks to you about a function f being continuous, and here's the graph of it. And it has 3 line segments, 1, 2, 3, and a semicircle. And they define that so that in case you need to find areas or you know that they're lines, that way you can easily find points on the graph. Things like that, so you know that this is not a parabola or some other type of function. Okay, and it says let g be the function given by this, and so g of x is the integral of the graph of f of x, okay? But it starts off from 1 to x. Now, whenever we have problems like this, if you remember in class, I like to do a little legend, okay? So let's see, what do the y values represent? Well, since this is the graph of f, then it's going to be my f of x. And what do the slopes represent? Then that will be the f prime of x. And so then I have the y values, I have the slopes, then the area, which would then be this integral right here. The integral from 1 to x of f of t dt, sorry if that's really small, is the area. But now I would like to know of this in terms of g of x. So if I do g of x, this is equal to g of x. That means this is g prime of x, and this is g double prime of x. Okay, you build over there, and I will help you in a few minutes. Okay, love? Okay, and so now, okay, that's really messy from your point of view. Let me just do this. G double prime of x, g prime of x, and this is g of x. Okay, and so now if I want to find the values of g of 2 is equal to, I replace this x with 2. Yes. I'm sorry, this is 2 of f of t dt. And so that represents the area from 1 to 2. Like so. And so you can see that that area is going to be negative because the entire area lies below the x-axis. So this is equal to, that area is a triangle, so it's going to be 1/2, base is 1, and the height, what is the height? The height is, well, let's see, if we go over 2, to the right 2 and down 1, so then if we go over 1, we must have gone down 1/2, so this is going to be negative 1/2. And so then the area is negative 1/4. And what is g of negative 2? That's going to be from 1 to negative 2 of f of t dt, which is equal to, well, here 1 is greater than negative 2, and usually we like to find our integrals where the lower value is the lower limit of integration. So it's going to be negative 2 to 1 of f of t dt. So if you remember, when we switch them, we get the negative value. Here's my phone, baby. Thank you. There you go. Go to your room. Oops. Okay. So that would be this area. Negative, and then what is the area? I'm going to start from over here. It's going to be 1/2, the base is 1, and the height is 3. That's the area of my triangle. And then this is a semicircle, but it's below the x-axis. So instead of adding the semicircle area, I'm going to subtract the semicircle area. And it's going to be pi. What is the radius? The radius is 1. 1 squared divided by 2 because it's a semicircle, if you remember. Now on the AP test, as I told you before, you can just leave your answer like this and you would get full credit for it. If you do simplify it, then I believe, let's see, this will turn positive. It will be pi over 2 minus 3 halves. Okay, but you can leave your answer like this and move on. All right, for part B, that was A. Part B, it says for each g prime of 3 and g double prime, find the value and state that it does not exist. Okay, so let's see, g prime of 3. G prime of 3. Well, here is g prime of x. G prime of x is the y values, which is f of x. So I'm going to replace my x with 3. So g prime of 3 is equal to f of 3, which is the y values. And all I have to do is look at the y values of f. Oh, excuse me. This is negative 3. Okay, so that's negative 2. This is negative 3. Like so. And so now I'm curious about what that y value is. Luckily, these are lines. So give me a second. And let's see, this is 1 to 3, so it's a rise of 2. And this is negative 4 to 2, so it's a rise of, or a run of 2. So that means it's 1 to 1, which therefore it means that this is negative 3, comma, 2. Which means then the y value is 2. That would be our answer. And what is g double prime of negative 3? Well, using our little legend, g double prime is the same thing as f prime of negative 3. And what is f prime? F prime is the slopes. So that means I'm going to go look at the same point and find the slope, which I just happened to find already, which is a slope of 1. Yeah, so easy. All right, now part C. Find the x-coordinate of each point at which the graph has a horizontal tangent line. For each of these points, determine whether g has a relative minimum, maximum, or neither. Blah, blah, blah. Justify? Okay. So first, I'm going to find out where it has a horizontal tangent, where g has a horizontal tangent. Okay, so g of x has a horizontal tangent when g prime of x is equal to 0. That's what I know. Okay, so now when does g prime of x equal to 0? G prime of x equals 0 at x equal to, well, let's see. Before I say x equal to, let me explain further. G prime of x is equal to f of x. That's when f prime of x equals 0. So at x equal to, sorry, not f prime, f of x. Lo siento. There's no prime there. When f of x equals 0. So now I want to look at when f of x equals 0. So that would be the y values. And so when are the y's 0? At x equal to, that looks like negative 1, and x equal to 1. Yeah, that's when it has a horizontal tangent. Okay, so you would get points for this and this. This is your justification, and there you have that. Okay, so now the next part is where g has a relative minimum or maximum. Okay, so let's look at x equal to negative 1. X equal to negative 1. So at x equal to negative 1, which is right here, you determine if it's a relative minimum or maximum by finding out if g prime changes sign. Okay, so g prime is the y values. So if I look at here the y value is 0. Here the y values are positive, and here the y values are negative. So when the first derivative changed from positive to negative, that means you have the relative maximum. Okay, so at x equal to negative 1, g of x has a relative max because g prime of x changes sign. I should not say changes sign, sorry. Changes from positive to negative, because it would be different if it was negative positive. Okay, so that's my first one. And then at x equal to 1, let me see what happens at x equal to 1. What happens to g prime? This is negative and that's negative, so it doesn't change the sign. So at x equal to 1, g of x does not, oh, you can't see that anymore, excuse me, there, does not have any relative extrema because g prime of x does not change sign. Okay? So your conclusion is this, and your justification is y. Okay? Your conclusion here was that it had a relative maximum, and this is your justification. Okay? Then, what's the next part? That was part C. Then part D. For -4 to 3, find all values of x for which the graph of g has a point of inflection. Okay, so point of inflection. G of x has a point of inflection at, okay, so before I state where, let's see, when does it have a point of inflection? Point of inflection is determined by the second derivative. And the second derivative are the slopes. And you have a point of inflection when your function changes concavity. Or in other words, your double prime changes sign. So I want to see when the slopes of the graph change sign. So I'm going to look at the slopes. So here the slope is positive. Here the slope is negative. I'm using a different color. Positive and then negative. Give me a second. And then down here, the slopes are negative. And here, the slopes are positive. And then the slope is negative. Okay. So where did it change sign? There's a change in sign right here. So at x equal to -2. There's no change in sign here. There's a change in sign right here at x equal to 0. And there's a change in sign here at x equal to 1. Okay, so g of x has a point of inflection at x equal to -2, 0, and 1 because g double prime of x changes sign. So this is your conclusion, and this is your justification. Of course, you want to write everything basically in complete sentences like I did. And that's it. I hope that this answers your question. Thank you.